So let's begin section 1, immunology, and just quickly read through everything, make sure we understand everything. So chapter 1. In this chapter, we're going to do an overview of the immune system. What the USMLE requires you to know are basically know the components of the innate and adaptive immune responses. So we'll review that in the end. Attributes of innate and adaptive immune responses, and interactions between innate and adaptive immune responses. So, what is the immune system? The immune system is designed to produce a coordinated response to the introduction of foreign substances or antigens into the body. It is organizationally divided into two complementary arms. There's the innate or the native or natural immune system, and then there's the adaptive or acquired or specific immune system. Okay, so what are they? Innate immunity provides the body's early line of defense against microbial invaders. It comprises 4 types of defensive barriers. So that would be, first of all, there's the anatomic or physical barrier. This is things like your skin, your mucous membranes. Then there's a physiologic barrier, which is things such as a change in temperature or your pH levels or chemicals such as the lysozymes in your mouth or the complement systems in your blood and some interferons, things of that nature. Then there's a phagocytic barrier where you have all your white blood cells such as monocytes, neutrophils, and macrophages attacking the invasive microbe. And then you have inflammatory events, the inflammation that starts as a result of microbial invaders. So that would be the innate immunity, the early line of defense. Now, innate immune defenses have in common that they are present. So all these anatomic, physiologic, phagocytic, and inflammatory events, what do they have in common? Basically, they are present intrinsically with or without previous stimulation. So they do not need to be stimulated. They're just there. Obviously, you'll just have skin there and your physiology is still there. Also, they have limited specificity for shared structures of microbes. They are not enhanced in activity by repeated exposure, and they have limited diversity of expression. So it makes sense because they are not enhanced in activity by repeated exposure. That makes sense because it doesn't matter how many times you're exposed to a microbe, your skin is not necessarily about to change usually. Limited diversity of expression. They don't change necessarily, they're just there. Have limited specificity for shared structures of microbes. Not quite sure what that means. Have limited specificity for shared structures of microbes. Like all microbes have a cell wall. They're not specific about things like that, maybe. Yeah. Okay. So once the barriers. So in a nutshell, the innate arm is basically your skin and mucous membranes, your temperature, pH, chemicals, complement and interferons. They're phagocytic, all the phagocytes, monocyte, neutrophils, and macrophages, and inflammatory events such as, they don't really mention examples of that, okay. And they're constantly present intrinsically, they're not specific, they have no memory, and then there is limited diversity. So once the barriers of the innate immune response have been breached, however, the adapted immune response is activated in an antigen-specific fashion to provide for the elimination of antigen and lasting protection from future challenge. So the components of the adapted immune system are basically your other set of lymphocytes. So monocytes, neutrophils, and macrophages were innate. They'd have no specificity basically. But lymphocytes, such as T cells and B cells, and plasma cells and cells of B lymphocyte differentiations, they are specifically adaptive. Antigen-presenting cells, such as macrophages, B cells, and dendritic cells. So remember, macrophages and monocytes are two different. Well, monocytes become macrophages. Monocytes are in blood, but once they get into this tissue, they become macrophages, from what I remember, which makes it specific, I suppose. Okay, so adaptive immune defenses have in common that they are specific, diverse, enhanced with each repeated exposure, and capable of self, non-self recognition and self-limiting. What does that mean? So we know that adaptive immune defenses, they are basically specific, obviously, because they're not just general, you know. So they will be specific for particular antigens and are specialized to provide the best protection. Right. They are diverse in their specificity. For instance, they will have a specific receptor for a specific type of antigen of a specific variant of a microbe. Enhanced with each repeated exposure, expresses immunologic memory. So if you get sick once, fine, it makes a response, and then the next time you get sick, you have a higher level of response. Capable of self, non-self recognition, very important, and it is self-limiting. It can stop itself, basically. Okay. So these would be the adaptive immunity. These features of adaptive immunity are designed to give the individual the best possible defense against disease. Right. Specificity, for instance, is required along with memory to protect against persistent or recurrent challenge. Okay. Diversity is required to protect against maximum number of potential pathogens. Obviously, specialization of function is necessary so that the most effective defense can be mounted against diverse challenges. The ability to distinguish between invaders and one's own cells and tissues, self versus non-self, is vital in inhibiting a response to one's own cells, autoimmunity. Self-limitation allows the system to return to a basal resting state after a challenge to conserve energy and prepare for the challenge by new microbes. Okay. Comparison of innate and adaptive immunity. So you have innate immunity and adaptive immunity, right? So is which one's specific and which one's adaptive? So in innate immunity, it is specific for structures shared by all microbes, but for adaptive, it's for specific antigens of microbes and non-microbial agents. Diversity-wise, its innate is limited, whereas adaptive immunity is highly diverse, so that it can protect against a maximum number of potential pathogens. Memory-wise, innate immunity has no memory, whereas adaptive immunity definitely has memory. That's self-explanatory. Self-reactivity. No, innate does not react to self, neither does the adaptive immunity. So what are the components of these two types of immunities? Basically, they have anatomic and chemical barriers, both of them. For innate immunity, your anatomic barriers would be things such as the skin and the mucosa. Your chemical barriers would be things such as the lysozyme, the interferons, alpha and beta, and other factors such as, environmental factors such as temperature and pH. This is all part of your innate immunity. It is not specific. It has no memory. It has, it's always there, and it's not very diverse. It's general, pretty much, very general. Whereas in adaptive immunity, what are the components of it? These are things like your lymph nodes, your spleen, your mucosal associated lymphoid tissues, things of that nature. That's where they are located. Also, well, there are not really that many chemical barriers, but it's just anatomic. But what they do, they're very specific, right? Because they have specific antigens of microbial for any microbial, non-microbial agents. They're also very diverse. They have memory. They get enhanced with every new exposure. Now, what cells are used in innate immunity? Now, we remember that it was the phagocytes, basically, and natural killer cells. We're talking about monocytes, we're talking about neutrophils, we're talking about uh, macrophages as well. So macrophages, look at that. It is part of innate and adaptive immunity. Interesting. Okay, remember that they're part of both, which makes sense because once activated, they can get inside inside the tissues. All right, so the innate and adaptive arms of immune response do not operate independently of one another. That makes sense because they depend on each other. So, what happens then instead? What happens is that the phagocytic cells, such as your monocytes, your macrophages, and neutrophils, they tend to process and display antigens to facilitate stimulation of specific T lymphocytes, probably TH zeros. Macrophages then will secrete immunoregulatory molecules, cytokines, which help trigger the initiation of specific immune. Actually, I'm gonna go to my handy handout here because it's easier to understand for me anyway. That's what I'm gonna do. I'm gonna zoom in here. I'm gonna find my macrophage. There's my macrophage. And we see that this line right there, macrophage will produce IL-12, which will activate the native T helper cell, basically, which will then activate IL, which will stop macrophages, which will bind to macrophage 2 first. Let's see how we can do this. We'll go here. We'll go halvesies here. Oh dear, it's very tiny. Anyway, and then we'll go full on here. That should be about right. Okay. So what happens is that you have a macrophage, right? Macrophage type 2, which is MHC2 molecule as well. In innate immunity, you have the macrophage. It gets activated and it becomes basically an antigen presenter cell with an MHC2 molecule. And so this kind of phagocytic cells, monocytes, neutrophils, things of that nature, they will process this antigen that they have acquired, and then they will go ahead and show this on top over here on their receptors. And what they will do is then they will then also produce IL-12, and they will kind of show it to look at what I found, And the macrophages will then also secrete immunoregulatory molecules, cytokines, and I believe it's IL-12, which will help trigger the initiation of specific immune responses. Then these T lymphocytes will then produce all these cytokines, right? Which will enhance the microbiocidal activities of phagocytes. So this will go back here and activate the macrophage again to start the kill response. Antibodies produced by plasma cells will bind to pathogens and activate the complement system to result in the destruction of the invaders. So here basically this T helper cell is going directly, it's becoming activated basically, and it seems like here we're activating the B cell. So we're going to activate IL-4, which will make the T helper cell into Th2, and then that will release all these three, yeah, IL-13, IL-4, interleukin 4, and IL-5, which will activate the B cell to start going through affinity maturations of B cells, depending on the antigen required. It's probably going to be IgG and then that's going to become IgG later. And so it's going to start producing all these cytokines, depending. And there you have it. Okay, so antibodies, here we go, antibodies produced, now this one becomes obviously plasma cells, produced by plasma cells bind to pathogens and activate the complement system to result in the destruction of the invaders. And these will go ahead and attack any of these invaders elsewhere, okay, in the microbe system, okay. Right. Antibodies produced by B lymphocytes bind to pathogens and assist with the phagocytosis. So opsonization, basically they'll bind to the microbe, opsonize, and then cause phagocytosis by macrophages. Here, see, there's the antigen microbe. So I should maybe make an arrow here. It's going to be annoying. Now it's like a multiple out with all of these. Box. Oh, I'm sorry, that does not work. And when we get the idea. Okay, so that's pretty explanatory. This is how they both work together. The macrophages display and activate the antibodies and complement enhance phagocytosis. Antibodies activate the complement. Cytokines stimulate adaptive and innate responses. Okay, then. Then what happens? Basically, let's go on to the next subject. Oh, we're done. Awesome. Here's a little interaction between innate and adaptive immune responses. So you have the innate barriers, which are your anatomic and everything else, anatomic, chemical, environmental. Well, they will be, see here they are, anatomic, skin, mucosa, cilia, things of that nature. And then you have the cellular neutrophils and macrophages activating the cytokine, which release the cytokines. They are also chemical, such as acid, lysozyme, complement. Anyway, they assist the phagocytosis and opsonization plus chemotaxis. So these chemicals will help activate the cells. So the cell will start producing cytokines, all these cytokines. And these cytokines will in turn go ahead and activate, oh, wait a second. Yeah, activate T lymphocytes and specifically Th0 to become Th2. Am I wrong? I hope not. Please tell me I'm not wrong. Yes, Th2. They will activate become Th2, which will then release cytokines, will further go ahead and activate T lymphocytes, and they will activate cells, cell-to-cell immunity, and at the same time activate B lymphocytes and antibodies will be produced. And This would be the acquired immunity part. Cytokines will also activate neutrophils and macrophages. We understand that. And where is this arrow even coming from? Activate. Oh, antibodies will activate chemicals, I think. Is that where it's at? Assists phagocytosis and opsonization. Perfect. Okay, interaction between innate and adaptive immune responses. The immune system has two arms, innate and adaptive. Agreed. The innate arm is a barrier system consisting of anatomic, physiologic, phagocytic, or inflammatory components. The innate arm is present intrinsically, has limited specificity and diversity, and is not enhanced by repeated exposure. The adaptive arm consists of B cells and T cells and antigen presenting cells, like macrophages. Adaptive immune responses are specific, diverse, self-limiting, capable of self versus non-self recognition, and display memory. The innate and adaptive arms interact with and augment each other through soluble substances such as antibodies, complements, and cytokines. This is one point I want to review again because I felt. So when we say specificity and memory to protect against persistent or recurrent challenges, specific meaning to an antigen, for instance. Memory meaning you remember from the last time you were infected. Diversity meaning it is able to deal with different types of microbes. Specialization of function is necessary so that most effective defense can be mounted against diverse challenges. So they're specialized. Each one is specialized, and then there's diversity. Okay. They do not attack your own body, so that you don't get autoimmune reactions. And it's limited because it can always go back to its normal state once the insult has been removed. Okay, pretty good for a first time. Let's see if I can stop this. Live stop. How do I pause this for a bit?